Hello everyone. So today I'll be talking about environmental and structural approaches to pest prevention, focusing on the greenhouses and nurseries. So these systems create control conditions ideal for crop growth, but unfortunately, they are also ideal for pest survival and production. Once pest enters, they spread quickly and control become very difficult and costly. So that's why prevention is always better than cure. In this presentation, we will explore how structural design and environmental management and preventive practices work together to keep pests out and crops healthy. So there are four guiding principles in pest prevention. The first one is the exclusion. So exclusion is keeping pests from entering in the first place. Second is avoidance. So avoidance is creating an environment where pests cannot establish easily. So third is suppression. So suppression is reducing the existing pest population before they reach damaging levels. And finally, monitoring. So monitoring is continuous observation for early detection so problems can be addressed before they spread. So these principles provide the foundation for all prevention strategies in protected cultivation. So structural design plays a crucial role in pest prevention. For example, the orientation of the greenhouse affects airflow and light penetration, which helps maintain a healthy microclimate. So seal joints and entry points prevent tiny pests from slipping through cracks, and using pest-proof building materials makes it harder for pests to hide, reproduce, or nest inside the structure. In short, a well-designed greenhouse is the first barrier against pest invasion. Physical barriers are simple yet powerful tools. So insect screens on vents and windows stop flying insects like whiteflies and thrips while still allowing air circulation. Double door entry system reduce the chance of pests coming in when workers move in and out. Netting can also be used as a temporary or seasonal measure, so these barriers form the first line of defense against unwanted pests. The location and layout of a nursery greatly influence pest risk. Elevated sites with good drainage prevent water stagnation, which reduces breeding grounds for root pests and water-loving insects. Isolation from surrounding fields or forests minimize pest migration. Windbreaks and buffer zones help reduce the movement of airborne pests. So by carefully selecting and designing the site, we can reduce many pest problems before planting even begins. Water is essential for plant growth, but it also supports pests and diseases when poorly managed. Overwatering can lead to root rots, fungus gnats, and mosquito breeding. The solution is precise irrigation. Water only when needed, guided by soil moisture monitoring tools. Proper drainage prevents standing water around pots and under benches. And drip irrigation reduces wet foliage, lowering the risk of foliar diseases. Managing water correctly means reducing pest-friendly conditions. Sanitation is another critical preventive measure. Regular removal of plant debris eliminates hiding and breeding sites for pests. Tools, containers, and working areas must be disinfected to prevent cross-contamination. A clean and organized nursery discourages pest buildup and makes monitoring easier. Just like in human health, cleanliness is plant production is the best medicine. Plant arrangement directly influences pest pressure. When plants are spaced properly, airflow improves, reduces humidity and the likelihood of fungal outbreaks. Good spacing also eliminates microclimates, those hidden humid spots where pests thrive. Finally, well-arranged plants make scouting and inspection much easier, improving the chances of early pest detection. So one of the biggest risks in nurseries is the introduction of pests through new plant materials. All new plants should be inspected carefully under magnification. They should be kept in quarantine zones with sticky traps and close monitoring. Dedicated tools should be used in these areas to prevent cross-use. If pests are detected, plants should be kept in isolation longer or destroyed if necessary. So this practice ensures that plants are not introduced into clean production area. Workers and visitors can unknowingly carry pests, spores, or eggs into the greenhouse. That's why entry must be controlled put limits on movement, visitor screening, and secure openings. Workers should follow strict hygiene protocols, including tool sanitation and foot bath, designated designated walking paths reduce cross-contamination between zones. Every person entering the greenhouse must play a role in protecting it from pests. Monitoring is the backbone of prevention. Sticky traps can detect flying insects like thrips and whiteflies early. Regular crop inspection, looking under leaves, stems, and soils are vital. Environmental monitoring is also important. For example, high humidity favors fungal pests, while low humidity favors mites. Keeping detailed records help track pest trends over time. The earlier pests are detected, the easier they are to manage. Even the strongest greenhouse weakens over time. That's why regular inspection for holes, tears, and cracks is essential. Any damage should be repaired immediately before pests exploit it. Surface treatments such as paints or coating can also deter pests from nesting on structures. A well-maintained greenhouse is a pest-resistant greenhouse. So there are two approaches to pest management: preventive and reactive. Preventive control happens before pests establish. It is long-term, sustainable, and cost-effective. Reactive control happens after pests cause problems, often involving chemical sprays which are costly and sometimes harmful. By prioritizing prevention, we reduce reliance on chemicals, save costs, and protect both crops and the environment. So in summary, pest prevention in greenhouses and nurseries depends on a combination of strategies, from structural design and site selection to sanitation, spacing, monitoring, and worker discipline. When prevention is prioritized, we save time, reduce costs, and build more sustainable production systems. The key message is this: strong structures and clean practices are the best pesticide. So with that,